So I'm hoping there's 4 trends you guys have to know. I'm hoping to get 2 of them today. So the first one is going to be, actually, before I even do that, can you all tell me what a radius is? You've taken geometry. What is it? It's from the center of a circle to the outer barrier. So if you have a circle, it's here to there. That is the radius. Well, what we're going to talk about first, the first of 4 trends that you all are going to be getting is the atomic radius. Again, there are 4 trends in the periodic table. That's why it's called the periodic table. There are periodic trends. Now, the size of an atom may be defined in a couple ways, 2 ways. Every atom is a different size. Everything on this periodic table behind me, all 118 elements, are represented by atoms. Carbon atoms, hydrogen atoms, uranium atoms, and so on. Every atom is a different size. There are small atoms, there are big atoms. No matter what element it is, you can determine its size, and their sizes, whether they're getting larger or getting smaller, can be determined with a trend on the periodic table. And this is why we use the periodic table as it is. So the first one is going to be the distance between the nucleus, which is the center, like what Connor was saying, or Kellen was saying in the beginning of the class, in the circle or the atom, between the nucleus and the outermost electron orbital. So if I have an atom here, that's the nucleus. This is the valence shell. See, outermost energy shell with electrons. That line right there is the atomic radius. So that's pretty straight up. The outermost energy cloud or electron cloud to the nucleus, that's the atomic radius. That's one way to determine the atomic radius of an atom. The other is half the distance between the nuclei, which is plural for nucleus, of 2 bonded atoms. So here's one atom. Here's another atom. There's a nucleus here. There's a nucleus there. There's the connection between the two of them. Half of that green line is the atomic radius. Now, as far as trends are concerned, I want to pull this image I found on Google down here. Come on. It's not moving. There we go. Okay. Now, as far as the trends in the periodic table, what we need to focus on, guys, are with representative elements only. So I need all of your focus today and tomorrow to be on the representative elements. That, in other words, that means the S block and the P block. These are going to be groups 1, 2, 13 through 18. You're not going to consider the D block. You are not going to consider the F block, because when you're determining the outermost electrons, that's really what's going to influence the size of these atoms, are the outermost electrons. And when I've told you before, calculating valence electrons is done by adding S and P. Yes, Varun.
Well, finding the second way that you said about finding the atomic radius, where you went halfway, what if the two atoms have like
different one, then you're going to have to go with the first one. If this is for things where you might have like O2, H2, they're called diatomic ion or diatomic molecules. What he's saying is, what if you have two atoms of different elements, like a big old uranium and a little tiny hydrogen? How is that going to affect it? Then you just need to go with the first method. Okay. All right. So guys, if you look at this diagram here, I want to make this very clear to you. This line I'm drawing separates the S block from the S block from the P block. So if you look at the S block, look at the second group. That should be a BE, not a BC. But you got beryllium, magnesium, calcium, strontium, and this is definitely weird. Should be BA, not SA. And then over here on the right, look at the first row: boron, carbon, nitrogen, oxygen, fluorine, neon. So what I'm trying to convey to you first, in order for you guys to get this, you got to see this first. You're skipping the D block. You're going straight from S to P. Okay, let's get that straight first. And the trends that we notice is when you go down a group, atomic radius increases. And I want to tell you why before I give you the other trend. This is going to be really important. Again, you're getting lessons within these lessons here. And these lessons within the lessons I'm teaching you will be very handy for the rest of the year. I want you to check this out. I'm going to teach you guys how to draw the entire first column. I'll actually draw the atoms. And I want you to see for yourself how they're getting bigger and bigger and bigger and bigger and bigger as you go down. Okay, so what we're going to do is I want to show you how these atoms right here, from hydrogen to lithium to sodium to potassium to rubidium to cesium, how they're getting bigger and bigger and bigger. So in order to do this, I need to teach you how to draw atoms. So I think the best teacher is experience and actually doing the thing. So let's do the first one. Hydrogen. What is hydrogen's atomic number, everybody? 1. How many valence electrons does it have? Or excuse me, how many total electrons does it have? 1. And so how many valence electrons does it have? Right. So what we're going to do is we're going to draw the nucleus right there. draw the first electron cloud, the first energy level, and put that one electron. That right there is an electron. That right there is a nucleus. So I got a couple questions for you. Is hydrogen stable by itself? Yes or no? No, it isn't. How many total electrons do you need on the first energy level, which we call the first principal energy level, in order for the atom to be complete? Very good. This doesn't have two. It has one. Okay, good. Now, let's go to lithium. Lithium has 3 total electrons. So I'm going to draw its nucleus here. How many? It has 3 electrons. How many electrons does it have on its first energy level? 2. Is the first energy level complete? Yes. How many total electrons do you need on the first level? Does it have enough to fill out the first one? Yes. What do we do with that third electron? Because lithium has an atomic number of 3. That means 3 protons, 3 electrons. We have 2 drawn. Where do I put the third one? Add another ring. What he means is energy level. We're now to the second energy level. Good. Okay, so riddle me this. And again, I'm asking the same questions on purpose because repetition helps your brains. How many total electrons does lithium have? Great. How many electrons does it have on the first energy level? What's the maximum number of electrons you can have on the first energy level? 2. So is lithium's first energy level complete? Yes. It has 3, like you said. So where do you put that third electron? On the second energy level. How many total electrons do you need on the second energy level to be complete? 8. Does it have 8? How many does it have? So is it stable? No. I want you to look at the atoms right now, though. Which atom is bigger, hydrogen or lithium? Exactly. So let's go on to the next one. We might do 2 more, and I think you'll start to see the trend. Let's do sodium. What is sodium's atomic number? 11. It has 11 protons. So how many electrons does it have? Great. How many go on the first energy level? 1, 2. How many go on the second energy level? 8. That's a total of 10 so far. Where do I put the last electron? On the third ring. How many electrons do you need on the third energy level to be complete? 8. You need 8 total every single time. The first one needs 2. Everything after that needs 8 to be stable. How many valence electrons does sodium appear to have? 1. Is sodium stable by itself? No. But what atom is currently bigger, hydrogen, lithium, or sodium? Yeah, see, I think you are. What do you notice in the trend? As you go down the periodic table, down a group, what happens to the size of the atom? It gets bigger. Exactly. Let's do one more to just put a exclamation point on this. Potassium, element number 19. How many protons does it have? 19. Where are all those protons, by the way? That's a unit 2 question. They're in the nucleus. How many electrons does it have? 19. How many electrons do I fit on the first energy level? 2. How many do I fit on the second energy level? 8. How many do I fit on the third energy level? 8. How many do I fit on the fourth energy level? 1. Okay, I'm going to ask you a series of questions. See if you can follow along. How many total electrons does potassium have? 19. How many can it have on its first energy level? Is the first energy level complete? How many electrons can it have on the second energy level? 8. Is the second energy level complete? Yes. How many electrons can it have on its third energy level? 8. Is the third energy level complete? Yes. How many electrons does it have on its fourth energy level? 1. Is this fourth energy level complete? No. Of the 4 atoms that we have here, which one is larger? Potassium. Now, if we did rubidium, you would have a 5th energy level. And if we did cesium, you would have 6. And if you did francium, you would have 7. So as you guys notice, as you go down, does the atomic radius increase or decrease? The atomic radius increases, and that's what we just indicated. But what I'm going to put on the test might make your brain kind of go a little cross-eyed, so to speak, get a little confused. You ready? What is the opposite of saying the atomic radius increases as you go down? It decreases as you go up. I will throw things like that at you at your test. So you gotta be able to spin it. You could say, what's the opposite of playing high school? Beating Steinbrenner. Steinbrenner lost to playing high school. So you got to look at it from both ways. So if you go up a group, atomic radius decreases. So I am warning you now. I will be trying to spin it both ways. Now, the other trend, what about going left to right? Well, you see right there, the atomic radius decreases. I'm going to tell you why. So when you go from left to right, the atomic radius decreases. What's another way to say that? Right to left is what? Yeah. And before I go any further, I see you, Varun. You're going to really need to practice this because you guys will get multiple choice options where you'll have a periodic table shaped like this. Look at this. And you'll have arrows pointing all different directions. You got to pick the one that's right. So from here, it increases. Sorry for my sloppy handwriting. And from this way, it decreases. Or you can have arrows go in the opposite direction. Sawyer, what's the opposite of having an arrow on the top going from left to right saying decreases? Right to left, and I could say what? Increases. So you got to watch out for that. Yes, Varun. I'm going to tell you. So I want you guys to look up here at me. And if you're watching online, you can see the trend here. But I'll say it loud enough. Look at boron. And then carbon, nitrogen, oxygen, fluorine, neon. What is happening to the atomic number? It's going up, okay? What does the atomic number represent? The number of protons. Now, for the atom to be neutral, if I touch this podium and I don't get shocked, that's because the atoms in this podium are neutral. What must the proton number equal? The electron number, so they cancel each other out. We call that a neutral charge. So if I have 5, 6, 7, 8, 9, 10 protons, I also finish my sentence. I have 5, 6, 7, 8, 9, 10 electrons. Okay. So Varun and others of you may be wondering, well, why does it get smaller? What is the charge of an electron? Negative. What is the charge of protons? Are protons attracted to electrons? Yes, they are. So if you have more electrons, or excuse me, or rephrase that. If you have more protons, you have a greater draw. You have a greater positive attractive force. And what is the one thing that positive attractive forces are drawn to? Negative forces. And so the more protons you have, the stronger the nucleus is. So see if you might be able to visualize this, okay? You have more protons in the nucleus. Are they going to be having a stronger draw towards those electrons or a weaker draw? Stronger. So what do you tend to do when you're drawn to something that you're attracted to. You bring it closer. So the fact that these elements are increasing their atomic number, which means that they are increasing the number of protons, they're increasing their positive charge. And if the positive charge is getting stronger and stronger and stronger and stronger and stronger and stronger, that means that they're pulling the electrons closer. Now, if you look at boron, look at that. Boron has 5 protons, 5 electrons. Carbon has 6 protons, 6 electrons. Which element do you think has a stronger pull on its electrons? The element with 5 protons or the element with 6? Yes. How about 6 versus 7? 7 versus 8. Get it? So as you get more protons, they get drawn in. Yeah.
So then how come you go back to S block, they're big again? It's so much.
Because you're going to the next energy level. And you're expanding the amount. The reason why these are getting bigger as you go down is because every level you have another level, another level, another level, another level. But here you're on the same level. You still have one. So watch this. We'll draw this out. I want you guys to help me out in drawing. We did lithium, okay? I want you to help me with beryllium. How many total electrons does beryllium have? 4. How many electrons go in the first energy level? 2. How many electrons go in the second energy level? 2. Is beryllium stable? No. But here's the thing, Connor. I want you all to hear this. I really hope, I really hope some of you have this moment, okay? Connor, how many total energy levels does lithium have? Right, 1, 2. How many does beryllium have? 1, 2. So have the energy levels changed? No, they haven't. What's the maximum number of energy levels they have? Okay, I just asked you. Let's try again. How many total orbitals? How many shells does lithium have? 1, 2. How many does beryllium have? 1, 2. Did the number of energy levels change? No. But lithium is element number 3. Beryllium is element number 4. Which one has more protons, lithium or beryllium? So beryllium has a greater positive charge to pull those electrons closer to the nucleus because the energy level didn't change. The number of electrons on the energy level did, but the energy level itself didn't change. So it's getting stronger, but it still is reaching out to the same level. So let's do carbon. Or not carbon. Yeah, carbon. No, boron, then carbon. Okay, here's boron. Guys, what is boron's atomic number? 5. How many electrons go in the first level? 2. How many go in the second level? 1, 2, 3. Connor, did the number of energy levels change? Did the number of electrons? Yeah, but did they go up a level? No, they stayed on the same level. And boron is element number 5. So it now has 5 protons pulling on those electrons, make them closer. Does boron or beryllium, yes or no, do they have to reach out any further than the other to grab the electrons? No, because what's the furthest energy level they both have? 2. That one has 2. This one has 2. The difference is beryllium has 4 protons to pull the electrons with. Boron has 5. And so it's pulling them in. Starting to make sense? Let's try carbon. Carbon is element number 6. How many electrons does carbon have on its first energy level? 1, 2. How many does it have on the second? 1, 2, 3, 4. Connor, does carbon have to reach out any further than boron or beryllium or lithium? No. But what does it have that's different? More protons. Does that mean it has a more positive charge? Is that going to attract the electrons more or less? That's how this works. It's pulling them in. I'll do one more. Neon. Skip to the end of the row. Neon is element number 10. How many electrons does it have on its first energy level? 2. How many on the second? 8. 1, 2, 3, 4, 5, 6, 7, 8. This has 10 protons it's going to use to pull those electrons in. So this is why the atomic radius decreases from left to right, but it increases from top to bottom. As you go to sodium, Connor, look at this. What's the difference between lithium and sodium? It has the third energy level. So do those protons have to work harder or less harder to pull those electrons in? They have to work harder, because what's different between lithium and sodium? Sodium has another level. You got to reach out even further to try to bring them in. So that's why it's increasing as you go down. As you go down, there's a new energy level you got to reach, which makes it harder. You know, it's easier for me to like grab Madeline's paper than yours. She's a lot closer. I'd have to work harder to get all the way out to you. The bigger the atoms get bigger as you go down, but they get smaller as you go from left to right, because the proton number is increasing, but the energy level isn't. You're on the same level. Are there any other questions with that? So if you have argon versus lithium, so argon is going to have 3 energy levels. Lithium only has 2. So let's look at the size. I don't know if we might be able to tell on this diagram. Looks like argon would be smaller, because it still, even though it has 3 energy levels, it has 18 protons to pull them in and make it tighter. Okay. Remember, guys, the whole key to understanding this is that protons are attracted to electrons, and protons can pull them in. The more protons you have, the more of a pull you have to bring those electrons in. Are there any questions with that? For sure. Garrett? I don't know if I'm convinced, Garrett. Okay. Okay, guys, this next part, what time is this class over? 11:30. We got about 9 minutes. This might very well carry over to the next class. This is a big topic here, okay? Ionic radius. All right. I'm very much expecting this to go into tomorrow. That's okay. In order for you guys to understand ionic radius, I got to get you started on what the heck an ion is. So here's how we're going to start this. This will be seen for the rest of the school year. So it's sad that we are missing about 3-4 people in this class. This is a big one. Atoms are able to gain or lose electrons. An atom that has an electron number that differs from the proton number is called an ion. I mean, gosh, this is big. This is a really big lesson. It's easy, but you don't know it yet, so it might be hard to start. An atom is neutral. I'm sitting in my chair. I'm holding this pen. I touch this podium, because the atoms that make up those objects have the same number of protons as electrons, so they cancel each other out. An atom does have a charge, because the number of protons and electrons are different. So to kind of give you an idea of this, I want to show you a cation. It is a positively charged ion. And what chem teachers have been doing since the dawn of chemistry is they say a cation is positive. You like that, Jackson? Might seem stupid, but you'll remember it. And that's what matters. A cation is positive. You have a cat? Yeah. Are you a dog guy? Me too. What kind of dog you have? A what?
Hound.
A hound? Wait, it just says to go bark. The opposite of a cation is an anion. This is a negatively charged ion. So let's see how well you guys are following along. Garrett, I want you to make me leave you alone. So in order for me to do that, and for you to do that, you need to answer a few things right, okay? I want to go back up for a second. Garrett, what is making the radius of these atoms getting bigger and bigger and bigger as you go down? And what occupies those energy levels? Very good. You're so far so good. So I'm going to ask you my first question. If you took away those electrons, would the radius get bigger or smaller? And if you added electrons, would the radius get bigger or smaller? That's the first thing. Very good. Starting to make me feel like I can leave you alone. Okay. So I want you guys to write this down. This is important. Increasing the number of electrons equals increasing the radius. It's getting bigger. It's getting more electrons. It's making the atom, or it's technically not an atom, it's an ion. It's getting bigger. And as Garrett also said, decreasing the number of electrons equals decreasing the radius. So let's do a couple examples. This is probably where we'll start to wrap up class because I have you guys for about 4 more minutes. Okay. I want to do sodium. And by the way, you guys may not have all these elements that we'll be using very often memorized, but it's going to be kind of like watching SpongeBob. No one quizzed you on what all the characters on SpongeBob are. But I bet you that you've watched it so much, you can probably memorize it just because it's like when you listen to a song. When Nick listens to Taylor Swift, he doesn't study the lyrics. He just listens to it so much, he remembers it. Right, Nick? So what element is Na? Sodium. And with that sound, I want to remind you guys that if I ever have to get up out of this chair and find out whose phone is on, you lose points that I give you at the end of the year or in the quarter for extra credit. So you need to walk in and put your phones on airplane mode. Sodium is Na. As an atom, it has to be neutral. So sodium has 11 protons, 11 electrons. Okay? As an ion, it has to be charged. Now, I want you all to remember this. This will make your life easier. The proton number never changes, ever. So whether you're doing an atom or an ion, it doesn't change. So how many protons does a sodium ion have? Okay. Its electron number is 10. And tomorrow, when I have more time, I'll teach you why. Why did it go from 11 to 10? I'll teach you that tomorrow. But here's what I want to gather, and this is what Garrett was getting at. Which of these has a bigger radius, everybody? The atom with 11 electrons or the ion with 10? Bingo. And by the way, sodium atom is Na. An ion. Look at the protons and electrons. What does it have more of? By how many? So you write Na with a little plus symbol in the top right corner like an exponent. And in chemistry, I say this to my AP Bio kids all the time. I'll start saying it with you. When the number is 1, you don't write 1. You just write the symbol. So that means positive 1. Let's try to do one more. Chlorine. Do this quick. Atom. 17 protons, 17 electrons. An ion. 17 protons, 18 electrons. What's bigger, a chlorine atom or a chlorine ion? An ion. Why is an ion radius bigger than an atom radius for this? More electrons. And one more thing before you go. What is that more of in the ion? Protons or electrons? By how many? So you put a little negative symbol. That means -1. We will continue this tomorrow. This is a big lesson. TBC, to be continued.